Greetings, everybody. Hey, you're in luck. We're going to take you to three of my favorite places today, Mercury, Venus, and Mars in Chapter 17. These are big, exciting, interesting worlds, actually pretty Earth-like in many ways. So we're only going to hit the high points. The interesting graphic here, though, that I particularly like is that notice Mercury, this is a to-scale view of four crucial planets: Mercury, Venus, Earth, and Mars. Notice that Earth and Venus, cement this in your head, are very close in size. In the old days, they used to call, this is a long time ago, when I was first starting to read astronomy books myself, they were actually calling Venus as probably Earth's twin, quote unquote. Boy, what a joke that is. As you'll see, it's more of a really hot place, as a matter of fact. Thick atmosphere, just a mess. And notice that even Mars is much smaller than the Earth, but Mars is considerably larger than Mercury and also further out in the solar system, so that means things are cooler. So let's go ahead and dive into this because there's a lot to talk about here. Here's Mercury in a nutshell. I like this planet a lot, even though it doesn't get as much press as the other two do. For example, on page 382, I recommend you take a look at the really nice table that shows the similarities between Mercury and the Moon. Now, basically, Mercury has a sort of a moon-like look on the surface. It has old craters, it has large basins. It looks like a planet that's been pushed around. No surface water, except at the poles. And I will talk about that in more detail. On the other hand, inside Mercury, it is actually more Earth-like than the Moon because it has this magnetic field. We'll get to in 3 seconds. Look at the numbers here. For Mercury, for the mass, it's 5% that of the Earth. Remember, these are the two most important things you can know about a planet: mass and solar distance. 5% of Earth, that's pretty small. That means that heat has been lost over the last 4.5 billion years while the planets have been in existence. And you wouldn't expect much to be there, would you? And the answer is no, you wouldn't. And that's what's so interesting about this. Solar distance, this is the closest planet to the Sun, 0.4 AUs. So that means it's 60% closer to the Sun than we are. Because of the low mass, it has a weak gravity, of course. And because it's so close to the Sun, it has high surface temperatures. You put those two things together, that is the prescription for very thin atmosphere, or none. And that's basically what Mercury is suffering from right now. The surface is airless, cratered, moon-like, except for scarps. I'll show you what that is in a minute. Here's the big shocker. Are you ready? Are you all sitting down? In the good old days, back when JPL was planning their first mission, I've heard these stories from people for years. They gave up on Mercury having a magnetic field and almost didn't put a magnetometer, which is an instrument that would have detected a magnetic field, almost didn't put it on the first mission. It was called Mariner 10. But then they finally decided, oh, we'll be hearing these guys whine for decades if we don't put it on here. So they put it on, and what happens? A big shocking thing happened. They discovered that Mercury has a magnetic field. Nobody to this day knows exactly why. It's only 1% as strong as Earth, but it looks just like Earth. It's obviously formed by a similar process. This implies that it's warmer in the core on Mercury than it should be, based on our rules of thumb. Okay, here's the surface of Mercury. It's a little dull and drab, I admit. It's got big craters. There's one right there. Here's another one right over here. Here's another crater. Here's another crater. These craters don't look exactly like moon craters, and they're not exactly like moon craters. But what's interesting is this strange thing right here. Does everybody see it? Here, I'll do this, zigzag across it. And initially the big question is this a volcanic flow that just is, that we're seeing the edge of here, or is this an actual fault? And it turns out that it's an actual fault because a volcanic flow would have covered up this wall as it passed over it and done a variety of other weird things. This is a fault, and this is apparently evidence of early on in Mercury's history when it was cooling very rapidly. Remember, it has this low mass. And as it cooled, the surface fractured in response to that. Here we're seeing, these things are all over the ancient portions of Mercury. They're called scarps. Okay, now we're going to graduate to Venus in a nutshell. Venus, however, boy, this is headline material. Venus has 82% of an Earth mass. That's humongous. And look at this, 0.7 AU. That means since the Earth is at 1 AU, that means that Venus is 30% closer to the Sun than we are. That is the fundamental beginning of its problems, as you'll see. Currently, the atmosphere is a mess. Thick, cloudy. It's always cloudy. The forecast on Venus is total overcast forever. The clouds are made of sulfuric acid. That's delightful. The atmosphere is made of CO2. There's no water. The surface is about 900 degrees Fahrenheit. That's what I said, friends. 900 degrees Fahrenheit everywhere. Day, nights, summer, winter. That's 480 C. And if that weren't enough, this is like a horror movie that won't end. The surface pressure is 95 atmospheres. 1 atmosphere is the pressure in the room right now where you're sitting. So Venus on the surface is very close to having 100 times the pressure of the Earth's surface. When you put all these things together, this is a place you're never going to go, but it is interesting to study it, and that's what people have done for some time now. Surface is like a hot, dusty desert. I'll show you a picture of that in a minute. But it is Earth-like in general terms. There are plains, there are big volcanoes, there are canyons, there are continents. It looks sort of like the Earth that got very hot and the water went away. Now, speaking of the water, early Venus may have had liquid water oceans. That doesn't square with anything I've said. It means that in the beginning, Venus was Earth-like, and then something happened and it became a wasteland, a very high temperature wasteland. And I'll explain to you a little bit about how that might have happened. Now, here's an interesting thing. Remember, Mercury was not supposed to have a magnetic field, and it does have one. And Venus might have been thought to have one because it's an Earth-like body, but it doesn't have one. It's not, none has ever been measured. However, this is the problem. It's a bad spinner. It rotates every 241 days, and it spins backwards relative to the Earth. Now, that's an anomalous thing for the solar system. Also, to give you a reference point here, it takes 225 days to go around the Sun once. So Venus's year is 225 days, and its day, so to speak, is actually longer, plus it's backwards. So something funny happened. It may have been that Venus got hit by a large asteroid early in its history, and that completely reset everything in the interior of Venus, or something else may have happened. In any case, Venus is an interesting case. It's definitely not a future for humans, however. Here's what Venus looks like. Now, because of the clouds, we can't see the surface, so you have to use radar imagery. You bounce radar waves off the surface, and the returns you actually synthesize into images. This is quite a technology. And what you see is stuff like this. This is a volcano, and boy, if I've ever seen a lava flow, this is it. There's one right there. So this is sort of Earth-like volcanism, lava flows, volcanic terrains, the whole bit. I'm not going to show you everything on Venus because we don't have time, but here's a picture that's really remarkable. This was taken by a spacecraft actually on the surface of Venus. And nobody's ever done that trick since the mid-1970s, and the Russians actually landed two spacecraft on Venus in 900 degrees at 95 atmospheres. Get the picture? And this is what it looks like. Sort of a rock heap that's very hot. And you can probably guess what happened to their spacecraft in a few minutes. They melted like an ice cream cone. Even though they were designed for the heat and the pressure, it's almost impossible in those days to make one that would last longer. But that's what it looks like. That's probably the greatest achievement of Russia in space, landing the first 2 spacecraft on Venus. Okay, back to the Venus runaway greenhouse effect. Here's what happened. Remember, Venus was 30% closer to the Sun than the Earth. That means it was always significantly hotter just because of this closeness. So it immediately it responded. If there were early oceans, which is probably true, the oceans began to evaporate rapidly because Venus was hotter than Earth, whereas that didn't happen here. Okay, and so once the oceans began to evaporate, since water vapor is a greenhouse gas, that meant that the greenhouse on Venus was enhanced by this evaporation. When the greenhouse began to trap more outgoing radiation, the temperature went up. That's what happens when the greenhouse gets stronger. The temperature goes up. And guess what happened when the temperature went up? You got more evaporation of water, and all of a sudden you have triggered a vicious terminal feedback effect that only ends in one way, and that is with the entire ocean evaporated on Venus and in the atmosphere. Of course, the temperatures go up hundreds of degrees. The planet is a total loss at that point. And you might think, well, wait, maybe if it cools down, the oceans will recondense and stuff. Not likely, because what happens is when all this water vapor gets high into the atmosphere, it gets hit by solar ultraviolet radiation. Remember the shortwave radiation that's pretty energetic? What happens is the UV radiation from the sun actually splits the water high in the atmosphere. The hydrogen is ripped away from the oxygens, and since hydrogen is so light, it says, "See you later, alligator," and escapes from the planet Venus. And it does this over a period of time enough so that the hydrogen on Venus is totally gone. You're left with a lot of oxygen and no capability of ever generating water again on Venus. So now, this happened probably 4 billion years ago on Venus, very early. It looks like something like this will happen here, but not for a while, because in the normal course of the aging of the sun, it gets brighter. That's a normal, non-pathologic thing. About 10% per billion years. It gets 10% brighter every billion years. So our future looks like in about 800 million years or so. It sounds like a long time, but that's really the prime of life for the Earth. What will happen is that our oceans will get triggered. Yours and mine will get triggered. And they'll start to evaporate, and they'll trigger the same feedback effect. This is a terrible thing, friends. There's nothing we can do about it because the sun is triggering it with its natural aging as it gets brighter. So, and the Earth's atmosphere will get completely evaporated. It will eventually escape the same way Venus's water escaped, and the Earth will be something like 850 degrees, give or take, Fahrenheit everywhere on the surface. That's a bleak prospect, I'm afraid. I guess if there's a silver lining to this thing, this same brightening of the sun will turn Mars into the garden spot of the solar system, if that's something that excites you. And all the Earthlings that are left will go to Mars, and they'll have a few 100 million years before it triggers Martian oceans and really ruins the solar system. But anyway, this is a real effect. It's occurred on Venus already. It will happen here in the distant future, and so forth. Now, here's Mars in a nutshell. Notice, let's look at the numbers. The mass of Mars is 10% of the Earth's mass. That's not big, but it's not small. It's kind of in the middle. Its solar distance means it's 50% further from the sun. That's what that means. And here's the key thing. Mars is the most Earth-like water world in the solar system, okay? And this is the site that is best by far for human colonization. SpaceX is getting a lot of press for their attempts to, because they're going to be sending humans to the space station. They're the ones that are actually planning to colonize Mars, send the first colonies to Mars, literally in the mid-2020s. Now, the mid-2020s is not that long from now. It may be 2025, it may be 2026, it may be 2027. We'll see how it goes. But they're talking about near-term human colonization of Mars. And so that's something to keep focused on as you watch this spectacle evolve. Mars, of course, is bigger than Mercury, but farther from the sun. So it's going to be warmer inside because of the higher mass and cooler on the surface because it's further away. Here's what its atmosphere looks like. 6 millibars, that means about 1% as thick as the atmosphere on the Earth. It's cold, that's what you'd expect. It has CO2 with water and other junk. It has dust clouds. It has big dust storms sometimes. And notice this, when you walk on the surface, and people will do this in a matter of only a few years, in my opinion, the gravity will only be 1/3 of Earth's gravity. So you will be able to jump 3 times as far on Mars as you can on the Earth. You'll be able to throw a football 3 times as far on Mars as you can. You'll be able to hit a golf ball 3 times as far. Mars has a huge canyon the size of the U.S., and this is on a planet that's much smaller than the U.S., much smaller than the Earth. It has the biggest volcanoes known. That's an interesting satellite. I'll show you that in 2 seconds. It has polar ice caps that are made of both water and CO2. This is a water world, and it has river network, seasonal changes. I kid you not, friends. This is an Earth-like planet. Some ancient impact craters, just to complete the picture. And as you might expect, early Mars probably had liquid water oceans, and there's a lot of reasons to believe that. Now, here's one of them. Here's this is an actual orbital image of the surface of Mars showing you actual drainage channels on the surface of Mars. You can see, look at the funny craters here that remind you of the moon, but boy, these things don't. There's nothing like that anywhere else like this. And this implies precipitation. That's right, the P word. And the precipitation could have been in the form of rain. It might have been in the form of snow. It might have been both. But these things are seen all over the ancient areas on Mars, so it was a widespread climatic thing. And here is, I was just telling you about the big volcanoes. This graphic shows you that Olympus Mons, that's the name of the largest volcano in the whole solar system. This is a fun place. And here's Mount Everest at 8848 meters. And here's Olympus Mons at 22,000 meters, 22 kilometers high. Is much bigger. Here's an actual synthetic image showing you what it looks like. This thing's the size of like someplace like New Mexico or something like that. Really a humongous volcano. One more before we go. Yeah, this is cool. NASA has actually done some systems level studies of small bases on Phobos. Phobos right here, this is an image of it. Phobos is about 15 kilometers long. That makes it about almost 10 miles long. Very small moon, which means its gravity is like a milli-g, a thousandth of a g, which is great for spacecraft. You don't even land on it. You just kind of sneak up on it and then grab it. And so it's very easy to move around it. And here's what they want to do. By the way, these are people, humans. Here's Mars in the background. And this is all sort of their off-the-shelf or soon-to-be off-the-shelf technology that they were showing you how they could assemble it to do a human exploration of Phobos. The Orion module is something that's being developed right now, as is all this other technology. And so the idea is to study Phobos while you're on Phobos, and also to study Mars while you're on Phobos. The reason, why would you not want to go to Mars? Well, we would want to, of course, but why would anybody choose to go to Phobos first? Because it's safer. The risk of sending humans to Phobos is much lower than actually sending them down to Mars, where on the first mission, there's a good chance you might lose them. So it'd be better to do your initial reconnaissance of Mars from the moons, and then later, when you're more comfortable, maybe in a year or whenever you want to, send up a lander to the Phobos base and take as many astronauts down to the surface as you want. So this is the sort of thing that, by the way, this type of a base on Phobos can be done at almost any time that people want to do it. There's no great technological leaps that have to be achieved. Okay,